Hey there, kiddos. Welcome to your video on setting up systems. All we're going to do today is take word problems and go from the word problems to the system of equations. We're not solving, we're not finding any answers, we're just writing equations, and that is it. So we're going to do 3 examples from the notes that you have in your packet. You'll have several ones that you leave blank. Feel free to go and use those as extra practice if you need to make sure you understand. I'll check anything that you do above and beyond, make sure you're on the right track. So start with number 3 here. Robert and Quinita both bought fruit baskets at the farmer's market. The contents and cost of each of their baskets is shown below. They lost their receipts and can't remember how much the unit price of an apple and pear. They don't know how much one apple and one pear are, but they do have their baskets. We need to write a system of equations that can be used to solve for the unit price of one apple and one pear. First thing we're going to do is write let statements, which is where we write a statement that says let the variable I choose represent this item. So I have apples and pears here. So my let statements are going to look something like this. I'm going to say let A equal apples. The purpose of a let statement is so that you will know what variable represents which part of the problem. It makes sense in this one because I'm going to use A for apples, but if I had wanted to use X and Y, then I would know X represented this part of the problem and Y represented this. It gives you so you know what the variables represent. So my other one, I'm also going to let P equal pears. So there are my 2 variables. I've identified them, I've defined them, I've told you what they are. Now we're going to write our equations. Well, I'm going to look at this first basket right here, and I can count and see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 apples. So 9 apples plus 1, 2, 3, 4, 5 pears is equal to $5.25. That equation matches what is in this basket. Now this basket over here has 1, 2, 3, 4, 5, 6, 7 apples and 4 pears, and that is equal to $4.10. Those are my 2 equations. You don't need to solve them. I don't really need to know how much one apple and one pear cost. All I want are the equations done. So now let's look at number 4. Number 4, it's very wordy. It's part of the reason it's on here, because you need to get used to having this stamina to read through a long problem and figure out what is being asked and what information you need. So suppose you were collecting tickets at a football game. Reserved seat tickets cost $4 each and general admission tickets cost $3 each. After the game is over, the turnstile count, that's that little thing you walk through at the fair or whatever, and it counts you as you go. It's called the turnstile. So the turnstile count shows that 1,787 people paid admission. You count a total of $5,792 from the sale of tickets. You're just about ready to leave for your post-game date when your boss says, hey, by the way, how many of each kind of ticket were they? Rather than spending half an hour sorting and counting all of the ticket stubs, you decide to use algebra. See, it does really happen in real life. Write a system of equations that will help you to determine the number. So let's first talk about the 2 things we have. We're talking about tickets at a football game, and there were 2 kinds. There were reserved seat tickets and general admission tickets. So I've got to do let statements. So I'm going to let X equal reserved seats, and I'm going to let Y equal general admission. Now there are going to be 2 types of equations here. One equation is going to deal with the total money, how much money got spent. The other equation is going to deal with the total number of people. So I have to write 2 different equations, one for just how many people there were and one for how much money there was. So let's start with the money, because this is usually the one that's the most intuitive, the easiest for people to get. So I know that reserved seat tickets are $4 each. So $4 for each of those plus $3, because general admission is $3, for each general admission ticket gave me a total of $5,792. So that takes care of the money. My tickets are $4 and $3. This is my total dollar amount. For the number of people, I no longer care how much the ticket cost. All I care is how many tickets there were. So reserved seat tickets plus general admission tickets gave me a total of 1,787 people. So the one that deals with money is where I put the ticket prices. The one that deals with people, I don't worry about how much the tickets cost because I just want to know how many there were. That's all there is. So here are your two equations. Done. So last one here, number 7. Marcus had 15 coins in nickels and quarters. He had 3 more quarters than nickels. Write a system of equations that could be used to determine how many nickels and dimes. It now says Randy. It should say Marcus. How many nickels and dimes Marcus has. So again, we've got to do our variables, so our let statement. So I've got nickels and quarters. They're my things I don't know. It should also say quarters. Wow, this problem has all kinds of issues. I'm glad that I came to it. Okay. So let's deal with our stuff. So we're going to let x equal nickels. And we're going to let y equal quarters. If you want to use different variables, feel free. These are just the two I've chosen to use. And so here's what I know. He's got 15 total. He's got 15 coins, nickels, and quarters. I'm just talking about a total amount of coins here. So again, I'm going to have two equations. One equation is going to deal with the amount of money that he has. No, it won't. I lied. Because this one doesn't give me a total amount of money. I'm going to have one equation that deals with the total number of coins he has. That will deal with just the total number, how many coins are there. And then the second equation is all about the 3 more quarters than nickels. So it's the info in the problem. So let's start with, we know he's got 15 total nickels and quarters. So nickels plus quarters is equal to 15 coins. It doesn't matter to me how much a nickel is worth or how much a quarter is worth at all. All I want to know is that's it, okay? He has 15 of them total. I also know that he has 3 more quarters than nickels. These kind of problems generally give people trouble because you read it one way, but then you write it a different way in algebra. So he had 3 more quarters than nickels. Whenever I have this kind of question and I read the sentence and I want to write an equation, I always ask myself, I go, self, what do I have more of? Well, according to this sentence, I have more quarters than I do nickels. That means the quarters gets to be all alone. The thing you have more of ends up by itself. Because then what I have to do is take the thing I have less of, which is nickels, and I have to add 3 to it. Here's how you need to think of that. If I have 3 more quarters than I have nickels, and I've got 3 nickels, then that means I have 6 quarters because I've got to take the nickels plus 3 to get the quarters. So the thing you have more of is what ends up by itself. So you need to always ask yourself that. Read that question and go, hey, self, what do I have more of? Oh, I have more quarters. That's all by itself. So these are my 2 equations, and that's it. We're not going to do anything else. You're done with that problem. So that is setting up systems. All you're going to do is read through the problem, determine what information is necessary so you can set up an equation, and then you're going to write your 2 equations. Use the extra questions on your notes if you'd like to practice a little bit more before you come to class. And I will see you guys tomorrow. Have a good rest of your day.